So now we're talking about anonymous functions. And to understand what anonymous functions are, we need to understand delegates. So if you have not understood delegates, then go back to the delegates video. So what an anonymous function is a function without a name. So that's literally an anonymous function. We usually use anonymous functions as delegates. Let me show you an example. I could do something like this. My action, right? So I just declare that delegate. And now I could have some kind of void foo, right? And print something. And now I could say my action equals foo, right? So that's a delegate action. And I pass to it a function. Okay. But this is not anonymous. This is a function that has a name and it has a return type and all these things, right? Like it's a normal function. So what is the difference between this and an anonymous function? An anonymous function is a function that has no name, and it is usually declared and defined in an expression. Let me show you what I mean. If I do this, we can get rid of this. Right, so now this looks similar to this, but you notice a few differences. First of all, let's just imagine that we are replacing this foo here with this, right? And then it starts to make some sense, maybe, hopefully. So basically we can look at this foo and there's this parentheses where we could have parameters, but we don't, right? So basically, if we imagine this foo here and then this here, right? Like just imagine that we have this declaration here. All we're doing is basically removing the name, right? And we're removing these curly braces and we are adding this arrow. Okay, that's all we're doing. And then I can call my action as a function because it is a function. I run this program and there we see the anonymous something. So we have executed this function here. Okay, so how does this work? Let's break it down. First of all, there is something here that we haven't seen yet, which is this arrow operator. This is called the lambda operator, okay? So it's basically just a C# operator, nothing special about it. We call it lambda, and it's this, yeah? And it's not only in C#, but in most modern programming languages, a lambda operator will be this operator. This lambda, you might know it from other, like from the Greek alphabet, right? Like it's a Greek word or a Greek letter. It's like this kind of thing, you know, like the half-life symbol. And what this lambda operator does in C# is it introduces a operation, like a function, right? So everything that is on the right side of a lambda operator, this is going to be a function. Okay. The usage of a lambda operator is mostly this one. There are a few other very niche usages that we will not cover, but this covers like 99% of the cases where you will see a lambda operator is to create an anonymous function. So again, if you think of the foo here, right, this is exactly what's happening. We have a function that has no name. We just removed the name. Here are the parameters. And now we are declaring the body of the function using this lambda operator. And then we have the body of the function. That's it. If we wanted to have a function with more than one line, then we could use curly braces. So we can also do something like this. And then we say, for instance, line 1 and line 2. And, oh, I forgot, there's a equals there. And there we see the line 1 and the line 2, right? So we can write just a normal function, like whatever function we want to write, we can write it here. And it has no name, right? Now, if there is no name, right, and we don't kind of declare it outside, it looks a bit like it's a completely different mechanism, right? So now there might be a question arising in your mind, which is, how does it actually work? If we think about the way that we learned about delegates and function pointers, we know that there's like, in the memory, here are the instructions, right? And we create a pointer, like a function pointer that points to some instruction there, right? Now this instruction, like let's say foo, right? It lives in this section of the memory. It was written by us and declared by us, and when we compile the program, it is there, right? And the mechanism for anonymous functions is exactly the same, literally the same. There is literally nothing different. So our pointer, when we have an anonymous function or an anonymous, when we have an anonymous function and then assign it to a pointer, somewhere in the memory, there will be our anonymous function. It will be there in the memory and we're just pointing to it. There's no magic in this stage. Where is the magic? The magic is, how does this anonymous function get there? And we know that in the case of the foo, we just write this, it gets compiled, it gets patched into, or not patched, but packed into the exe, right? And the very simple explanation is, well, this also just gets packed into the exe. There's really nothing special about this. The compiler takes this function, writes it as a normal function in the exe, and it gives it some kind of name, some kind of ID that it can recognize. And then when the computer loads our instructions, it will also load this anonymous function, which at that point is actually not anonymous anymore. It needs to have some kind of ID, some kind of memory address, some way of being addressed, right? So this anonymous part, the anonymous is only for us, for the devs. The computer knows exactly what this function is, yeah? Like computer, or let's call it maybe the compiler. The compiler gives it a name. So actually, this is not anonymous for the computer. Yeah. So it's really only anonymous for us when we write it, because we do not need to give it a name. And for the computer, it is never anonymous because the compiler needs to generate. And indeed, what the compiler will do, if you would look at the intermediate language, what the compiler does is it just creates a function like that. So the behind the scenes sort of thing is that it creates a function with some random name. It will be a name like this, yeah, which is just a random string of characters. It takes that, puts it there, and then it says that this equals that. Okay, this is literally what the compiler is doing. And you can, if you want, you can go and check like the intermediate language specifications, or the intermediate language stuff about that. Again, we will not get into that specific rabbit hole, but If you are interested, please feel free to research this. But I can tell you, this is literally what's happening. So really, it's not that the function is different. It's just a compiler trick to make our life easier. And how does this make our life easier? Well, because often we have this sort of situation where we have like a delegate and we want to pass something to it that we're not actually going to reuse. Like we only want this function. The only reason for this function to exist is to pass it to a delegate, which will then be passed to a different class or to a different function or to a different whatever piece of code. And we will not actually reuse it. And if we're not reusing it, we don't need to have a function like this with a name. Like the whole point of having a function with a name is that you can reuse it. So you don't have to rewrite this code every time, right? Like then you just talk about this piece of code, this algorithm, whatever it is, you just call it by this function name, right? That's the whole point. But if we don't want that, and we just want to pass this function as a pointer, then we can make an anonymous function. I will add one thing, which is about events. So let's say that we have an event. I will make a class foo here. And we will have a public event action foo changed. And I will have here a change foo, and all we're doing is then invoking this. Okay. Now, one thing about events that you will often see is that people will use anonymous functions to subscribe to events. So let me show you. Let's do something like this. Foo equals new foo. And then we say f.foo changed plus equals. And then I say, right, something like that. Now, this is fine. You will see this sort of pattern very often. This is okay. The problem is when I want to desubscribe. Okay, so let me just show you here. I change foo. I will run this and I see the foo changed, right? So I call this invokes the event, and then it calls this function that was passed. Okay. If this doesn't make sense, please go back to the events video. So now the problem comes when I want to desubscribe. Let me go here and do this. I will copy paste this. I will remove this, and then I will invoke the foo again, right? And we see that foo changed gets printed twice, even though theoretically I am desubscribing here. So what's the problem? The problem is that, remember that I said the compiler comes here and does like a random name for this function, right? The thing is, every time you have this a lambda expression, the compiler creates a new class with a new, not a new class, sorry, a new function. So basically, in this case, the compiler has created two different functions with two different names, right? And then basically it does this, and then when you remove it, it removes this one. And they are not the same. So when you do this, it actually does not remove the initial one, right? Because for each lambda, you get a new function that the compiler creates. This is why it's important to understand that these anonymous functions are actually not like anonymous. Yeah, the compiler is actually creating a function. So that's why this would not work. So for events, you do not do this. Like, seriously, do not do this. I know that a lot of tutorials do this, a lot of tutorials show you like this, but those tutorials, they are not worried about what happens when this object is destroyed or something like that. Yeah, because often those tutorials, they are just showing you how to set up this thing or how to do this like very specific, very small thing And then they show you, oh, you can use an event, and you just do it like that. Fine. But when you have like an actual big project where things are being created, destroyed, like let's say in Unity or in any game engine, you have like scenes and objects being loaded, unloaded, assets being loaded, unloaded, and stuff like that, and scripts and components, like tons and tons and tons and tons of stuff, and things are being destroyed, then you could have a situation where you will need to unsubscribe because, you know, something was destroyed and you want to unsubscribe from this event. And this will not work. Okay, so how do you fix this? You create a variable. You say action, and then you say something like event handler, right? We know that the event handler is basically this function. And you just say, okay, you take this anonymous function. It can still be an anonymous function. It's fine. But you just assign it to a variable. And now you only see it being printed once. So now you might have a question about what if my function needs to return a value or take parameters, because here we just have a normal action. So I will show you what if the action has some parameters. So we have an action with an int, and I'll just go like int delegate. And all we need to do is just have some parameter here inside of the parentheses. We don't even need to specify the type, right? I don't need to do this as I would for a normal function. And then, for instance, I can print the A, right? So I can have the type here, but I don't even need to, because it is the compiler figures it out, because it knows that the signature of this delegate requires an int, so this must be an int, yeah? So you could declare it like this, as if you were writing a normal function, but you don't need to. Okay, so then I can call this int delegate, and I can do 1, and then it will print a 1, right? Or I can do, you know, this number 234, and it prints the 234 there. Okay, what if I need to return a value? No problem. Let's do a func. And this func will return a bool, okay? And we'll say bool delegate, no parameters, right? It has no input. And now what I will say is I can just write here after the lambda, the value that I wish to return. So I can say, for instance, true. I just return true. That's it. And now what I can do is I can print that out. So I can print bool delegate. So I run the function, I take the return value, and I print it. So this will print true. If I go here and I write false, it will print false. You can also do it with some input. So I will go and say like int. And then what I will do, I will have an A, and then what I'll print is if A is less than 10, right? So then I can say, okay, let's print, let's go with 3. So it will basically pass this 3 into the function, right, as the A. So the 3 becomes the A. Then this will be 3. 3 is less than 10. That's true. So the return value will be true, and we will print true, right? And then I'll do this with 15, right? And then we will print false. True and false. Okay. One difference with this is that if you want to, let's say, if you want to have some different things, like if you want to have one of these kinds of lambdas, right? So instead of having like just one expression, you want to actually have a series of statements. You want to have several lines. Then you need to actually use the return keyword, because notice here we do not use the return keyword because return is implicit, right? Basically, we have a function that only has one line, and the compiler knows that, hey, If this function must return something and it only has one line, then this line must be the return thing. It must return something already, because you don't have two lines, right? Like it's the only line, so this has to return something. But if we have multiple lines, then we need to do something else. Let me show you. I was highlighting this one, but actually I wanted to highlight this one. I am sorry. But what I can do is bool delegate equals, and I have my A here, and then I can say lambda, and then I can have this body here. Notice I need to do this. I need to have a semicolon. And then, you know, I could print out something. So I could say bool delegate, and then I need to return. And then I need to use the return keyword. Return A is bigger than 10 in this case. Okay. So if I want to have more than one line, I need to use the return keyword, because again, the compiler does not know which of these lines should return something. Whereas here, it's very clear, there's only one line, so this one must return something. Okay, and another thing that you might see quite often is the use of discards. What is a discard? It's basically a variable that you do not use. It is left unassigned. The compiler will just ignore it. So if I have something like this, like a float action, let's say that I could, you know, pass here my float. I'll just call it f, and then I could print the f, right? So that's basically what we're doing here with the int. Right, so I would then print 1.0, or in this case, just 1. What I could also do is, let's say I don't want to print the actual f. I just want to print something like float delegate was called, right? So now I'm not using that f at all, right? So I could also tell the compiler, like, hey, I don't want to use it. I don't want to use this variable at all. Like, just leave it, ignore it, okay? And then whatever value I pass, it will just be ignored by the compiler, right? We can also do this when we have multiple values. Something like this, right? Oh, and yeah, of course, I need to change this now. And you see, nothing happens. We don't get any runtime errors or anything like that. And here it says it in parentheses, it says discard, right? So it's a discarded variable. It has no value. If I try to use it here, right? So if I try to use it here, I will get a compile error. I will get a compile error. It says the name does not exist in the current context. So these are not actual variable names. They are discarded. Okay, I can still pass values to these parameters. They will just not be present inside of the function. This is useful sometimes for when you have a certain object, like let's say that this parameter, or that this the input parameters would not be like 2 parameters, but rather many parameters, like 5 or 6, and you don't want to assign them all, like you don't want to use them all, and you want to be explicit, like you have a little bit of a bigger function and you just want to be explicit about, hey, I'm not using this one, right? Like you can say, I'm using the first one, like let's say you have a bunch of them and you just want to tell everyone in your team, let's say, hey, I'm using only the first one, right? Like, so here you would have, how many do I have? 4, right? So you would have something like this, and then you would just say, okay, in this case, these ones don't matter, right? The function is only going to use the first one. Yeah, so it's just a way of like communicating through your code. Okay, that is anonymous functions and lambda expressions.